Hi guys, we're going to be talking about segment relationships in circles this time. Before, in the last section, we talked about angle relationships in circles. So now we're moving on to segments, so get pumped up. All right, let's get going. So the first type of relationship we're going to talk about are chords that are intersecting inside of the circle, which I'm going to call this the chord property. Guys, so basically, in this circle, we're going to have chords AC and DB. Okay, so if two chords intersect on the inside of a circle, then the product of the two segments of the first chord, so if we look at the first chord, if we multiply the two segments that make up the first chord, that will equal the product of the two segments from the second chord. So if we break down the second chord into two segments and multiply them together, it will equal the first relationship that we talked about. Okay, so I know you're probably like, the song, I don't even understand what that means. Well, it will probably make more sense when I go over this. So let's talk about what the product of the two segments of the first chord means. Okay, so what that means, if I look at my first chord, which is chord AC, if I multiply the two segments within that chord, which are segments AE and EC, that will equal the same kind of relationship with the other chord. So if I look at chord DB, okay, that will equal the product of the two segments from the second chord, which means if I multiply the two segments that make up chord DB, so DE and EB, that will equal my first relationship. So basically, we're breaking down each chord into two segments and multiplying them together, and that relationship will equal each other. Pretty nifty, right? I know. All right, so we're going to be using this nifty property in example 1 and 2. So go ahead and pause the video and find the value of x and the length, if I can talk today, the length of each chord. Funsy time is later on. Wait for it. All right, the second property we're going to talk about are when secants are intersecting outside of the circle this time. Whoa. And I'm going to call this the secant roll. So basically, all this is trying to say one simple thing, which I'll read it to you, but you might get it. I don't want to say you're not going to get it, but it's kind of a lot to take in. So if two secants intersect on the outside of a circle, so like currently I have secants AC and CE, okay? The first secant and the external segment equals the product of the sum of the two segments of the second secant and the external segment, which again, that's a bunch of kind of mumbo jumbo, so I need to break down what that means. Okay, so basically we're going to multiply the external segment by the length of the entire secant, which two segments are within secant AC, which two segments are within it, so I can find the length of the whole thing. They are AB and BC, so if I add AB to BC, that will give me the length of the entire secant AC. So we're going to add BC to AB, okay? And that will equal the external segment of the other secant, so the part on the outside of the circle, which is DC, times the length of the entire secant segment, which two segments make up the secant C to the E? They are CD and DE, so we're going to add those bad boys together. Guys, so the shorthand for this rule, the way that I like to go through it, basically we're multiplying an outer segment times the outer plus the inner segment. And on the other secant, we're multiplying the outer segment times the outer plus inner. So outer times outer plus inner equals outer times outer plus inner. So I don't know if that helps you, but that's kind of the way I visualize it. All right, so we're now going to use this property to help us find the value of x and z and the length of each secant segment, that's hard to say, in example 3 and 4. So go ahead and pause the video and watch example 3 and 4. Funsies will be great, but not yet. All right, so the final property we're going to talk about are tangents and secants intersecting outside the circle. Holy to the hot dog. Okay, I'm going to call this the tangent secant roll. Okay, so we're going to have a circle with a tangent, which in this case, the tangent piece is CD. Okay, and the secant is A to the C. Okay, so again, I'm going to read the rule, but it's a bunch of mumbo jumbo in my opinion. I'll break it down later on. So if a tangent and a secant intersect on the outside of a circle, then the product of the sum of the two segments of the secant and the external segment equals the tangent segment squared. That is a mouthful. Okay, so let's break this down. So we're going to start with the secant. Okay, and this rule is going to look very similar to when we did the rule over here. Okay, when we did our secant rule, we did the outer segment times the outer plus the inner segment. Well, guess what? This is going to follow the same protocol. So we're going to have the outer segment times the outer plus inner segment. That is on the secant segment. Now that will equal the tangent segment squared, or the way I like to say it, squared. Okay, so the secant line, or in this case it's a segment, the secant segment kind of flows the same way as the last property. The only thing that's different is now it equals the tangent piece squared. Okay, which this one's my favorite property, so we're going to have fun with that. So go ahead and pause the video so you can find the value of x and y in example 5 and 6. Nice job, you guys. I hope you love working through these segment properties as much as I did. Actually, I know you did because you love doing this stuff. I know you do.